All right, let's just jump right in. We're going to tackle a question that's, well, it's one of the biggest, most mind-bending questions out there. And it all starts with something ridiculously small and incredibly fast. And it ends with, the most complex thing we can even imagine, our own consciousness. I mean, think about it. How does the physical stuff out there become the movie playing inside your head? So in this explainer, that's exactly what we're going to do. We're going to follow the journey of one single particle of light, a photon, all the way from the outside world right into the deepest parts of your mind. It's going to be a wild ride. Okay, so let's meet our little hero, the photon. You can think of it as a tiny packet of energy. And seriously, everything you've ever seen, ever, it's all thanks to these guys. But here's the crazy part. The light that we can actually see, it's just this teeny tiny sliver of all the energy zipping around the universe on the electromagnetic spectrum. All right, first stop on our photon's big adventure, the eye. And let's be clear, this is not just some squishy eyeball. It is an unbelievably sophisticated piece of biological hardware. It's like a camera that's had millions of years of R&D. And this journey through the eye, it happens in a flash. First, bam, it hits the cornea, which bends the light. Then it zips through the pupil. That's the aperture your iris controls, and the lens behind it does all the fine-tuning for focus. And then it reaches its final destination, the retina at the very back. Now, this entire intricate system at the front of your eye, it has one job, and one job only, to focus a perfectly sharp image onto that retina. But, and this is our first really weird twist, because of the physics of a lens, that perfectly sharp image is completely upside down and backward. Yeah, your brain is getting an inverted picture of the world. But here's the thing, that focusing mechanism, it's actually pretty delicate. And when it goes wrong, you get short-sightedness or myopia. And right now, we are living through a global myopia epidemic. I mean, get this. In China, 60 years ago, maybe 20% of the population was short-sighted. Today, it's up to 90% for teenagers and young adults. And that's not even the worst of it. You look at a place like Seoul, and you see a jaw-dropping 96.5% of 19-year-old men are short-sighted. Let that sink in. Something is going seriously, fundamentally wrong with our eyes. So what's going on here? You're probably thinking it's all our screens, right? Or maybe reading too much? Well, the actual answer? It's probably not what you think. The research is pointing to one surprising culprit, a lack of bright outdoor light. It turns out that kids need that super bright sunlight for their eyes to develop properly. It's fascinating stuff, but that's a whole other explainer. For now, let's get back to our photon. Okay, so our photon has successfully navigated the lens. It's hurtling toward the retina. And this is where the real magic happens. This is the moment a particle from the outside world becomes a part of you. It's where light literally turns into an electrical signal. All right, you gotta wrap your head around this next part because it is completely backward from what you'd expect. In any camera you've ever used, light hits a sensor and the sensor turns on, right? Makes sense. Well, your eye does the exact opposite. For a photoreceptor cell to tell your brain, hey, I see light, it has to turn off. So here's how this crazy process works. In total darkness, your photoreceptor cells are actually humming along. They're active, they're on. They're what scientists call depolarized. But when our little photon comes along and smacks into a special molecule, it sets off this incredible chain reaction that basically slams all the cells shut. This all goes silent. It turns off. It becomes hyperpolarized. And that sudden change from on to off, that is the signal for light. It's the silence that the brain is listening for. Okay, so we have our signal, but it doesn't just get zapped straight to the brain. Not even close. The retina itself is actually a little slice of your brain that's in your eye. It's like a mini computer that starts processing the image right away, creating a sort of first draft of what you're seeing. But this little computer seems to have a huge, glaring design flaw. I mean, it looks like it's wired completely backward. The actual light sensors, the photoreceptors, they're buried at the very back, so our photon has to blast its way through a whole mess of other cells and wiring just to get there. Why on earth would it be designed like that? Well, it turns out nature is way smarter than we are. It has some incredibly elegant workarounds. For one, all those cells in the way, they're basically transparent. And in the fovea, the spot where your vision is sharpest, the wiring is literally parted, pushed to the side to create a clear path. But the coolest solution is the third one. This is just genius. The retina has these amazing things called Muller cells. And what they are living biological fiber optic cables. They stretch all the way through the retina, grabbing photons at the front and funneling them perfectly to the photoreceptors at the back with almost no distortion. It's an absolutely brilliant solution to what seemed like a terrible problem.
So, you see, the retina isn't just like the sensor in your camera counting pixels. No way. It's actively looking for stuff. Its circuitry is designed to find edges and contrast. It has some cells that fire when they see a bright spot in a dark background, and other cells that do the opposite. It's already drawing a rough sketch of the world before the information ever leaves your eyeball.
All right, now that rough sketch is ready to go, it leaves the eye through the optic nerve. But it's not traveling down a single road. The information is split and sent down multiple parallel highways, with each highway carrying a different kind of traffic. This split happens thanks to different kinds of cells. You've got your midget and bistratified cells. Think of these as the detail-oriented artists. They're obsessed with form, fine detail, and color. Their info goes to the brain's what stream. Then you have your parasol cells. These guys are the action heroes. They only care about motion, location, and depth. They feed into the where or how stream. So, to put it simply, your brain processes vision on two separate highways at the same time. The what stream is for recognition. It lets you look at a cup and think, that's a coffee cup. The where/how stream is for action. It's the system that knows exactly where that cup is, so you can just reach out and grab it, probably without even consciously thinking about the movement at all. Usually, these two streams are woven together so perfectly that we just experience a single, seamless reality. But what happens if you cut one of the streams? A very rare condition gives us a shocking look at what happens when these two parts of vision get disconnected. Let me tell you about a man known as Patient DB. After surgery, his what stream was destroyed. As far as he was concerned, he was completely blind on his left side. He could not consciously see a thing. But here's the wild part. When scientists asked him to point to a light in his blind area, he could do it perfectly. He would insist he was just guessing, that he saw nothing, but his hand knew exactly where to go. His where/how stream was working just fine, guiding his body, even though his conscious mind was in the dark. It's a condition called blind sight. And that brings us to the final, profound question of our journey. If a person can interact with the world, point to things, catch a ball, but has zero conscious experience of seeing it, are they truly seeing? Our Photon's journey started as a simple physics problem, and it's ended at the very edge of consciousness itself. It just goes to show you that simple, everyday act of opening your eyes and looking at the world is so much deeper and so much stranger than you could possibly imagine.